In this stoichiometry class, we want to consider the mole relationship. We want to consider the mole relationship with, number one, we want to consider mole relationship with substance of known masses. Mole relationship with substance of known masses. Number two, we'll consider mole relationship with solution concentration. Solution concentration. So we'll consider mole relationship with substance of known masses, mole relationship with solution concentration. Number three, the mole relationship with gases at standard temperature and pressure. That is STP. All right. So we'll consider mole relationship with gases at standard temperature and pressure as STP. Number four, we're going to consider mole relationship with ideal gas. Okay, or ideal gases. Then number five, we are going to consider mole relationship with elementary particles. Elementary particles. All right, now let's start with the first one. Let's pick another pen. Let's pick up the pen. Mole relationship with substance of known masses. What does that mean? The formula to use for solving problem of that nature is that number of mole of substance is equals to the mass of that substance over the molar mass. The mass of that substance over the molar mass. Now, consider this question. Let's say you are asked, calculate the number of mole of sodium triiosocarbonate 4 in 60 gram of sodium triiosocarbonate 4. All right. Now, to solve this problem, you need to know that number of mole is equals to mass over the molar mass. Please, the mass of the substance here is 60 grams. So we have 60 grams. Then the molar mass there, which is supposed to be in gram per mole, should be sodium triiosocarbonate 4, sorry. Sodium is 23. 23 times by 2 of those, because we have 2 sodium. Carbon is 12. And oxygen is 16. 16 times by 3, we'll have 48. So we have here should be 46. Here should be 12. Here should be 16 times 3, that is 48. And I shall have a total of 106 gram per mole. All right, so this is the molar mass. The molar mass is 106 gram per mole. So I'm going to be adding 106 gram per mole over here. So that 60 will cancel 106 and I'll get my answer. So let's pick up the answer. What do we have? We have 60 divide by 106. That will give me 0.566 mole. So my answer will be 0.566 mole. So that's the final answer. Now let's get to the next one. Over there on the board. Okay, so let's put the formula here first. Now for the next one, you need to know that molarity, we're talking about mole concept with this one. This is number 2 now. This is number 1, which is this first one. Mole relationship with substance of known masses. This is number 2, mole relationship with solution concentration. Now, for solution concentration, you need to know the molarity. Molarity is simply the number of mole over the volume. Number of mole is, the unit for number of mole is mole. The volume should be in dmq or in liter. But I love using dmq, so let's just add a dmq, so that my equation will be equals to mole per dmq. All right, so now can I put a 1 here and then cross multiply? If I do that, what I'll be having is number of mole is equals to molarity times by volume. All right, let's say we have a question. Let's say we have a question, and the question is calculate the number of mole in 500 cm3 solution, 500 cm3 solution of 0.05 mole dmq of H2SO4. All right, I have this. Calculate the number of mole in 500 cm3 solution of 0.05 mole dmq H2SO4. Recall that the number of mole, the molarity is equals to number of mole over the volume. So that if I put a 1 here and cross multiply, number of mole is molarity times by volume. Now, the molarity here is 0.05, which is equals to number of mole, I don't know that, so I'm going to put X over there. All right, so if I put an X over there, and then the volume is 500 cm3, I'm going to convert volume to dmq by dividing 500 by 1000, because my unit shows that mole calculation is done in dmq or in liter anyway. All right, let me divide 500 divide by 1000. That will give me 0.5. Okay, so I have 0.5. If I should put a 1 here and cross multiply, X is equals to 0.05 times by 0.5. So I'm going to get the number of mole if I do that. All right? So I have 0.05 multiplied by 0.5. What do I have? I have 0.025. What I have is 0.025 mole. All right, so that's how to solve problem like that. Let's go to the next one. The next one is number 3. Number 3, which is the mole relationship with gases at standard temperature, gases at STP. All right, number of mole for gases at STP, remember it should be at STP, is the volume of gas in dmq divided by 22.4 dmq per mole. All right, let me take that formula again. The mole relationship with gases at standard temperature, the number of mole, because this is number of mole, N is definitely equals to the volume in dmq over 22.4 dmq per mole. Now, what's the meaning of 22.4 dmq per mole? Now, this is because for every gas, for any gas, 1 mole of gas at STP contains the volume in dmq And that volume in dmq is 22.4 dmq. All right, so let me remove the dmq. All right, now at 1 mole of gas at STP contains a volume of 22.4 dmq. Are you following that now? Now, for the number of mole of gases at STP, it is the volume of gas divided by 22.4 dmq per mole, because 1 mole of gas at STP contains 22.4 dmq. If your question is in cmq, convert to dmq. Let's have a question. Calculate the number of mole of let's say 20 cmq of hydrogen gas at STP. So very easy. Calculate the number of mole of 20 cmq of hydrogen gas at STP. Now what do we do? Now number of mole is equals to that guy volume in dmq over 22.4 dmq per mole. All right. Now let me change another pen. What's my volume? Volume is 20 cmq. To convert 20 cmq to dmq, divide by 1000. I think it's going to give you 0.02. But let's confirm that. Let me try. 20 divided by 1000. Okay, 0.02. So I have 0.02 divided by 22.4. That is in dmq. Understand that dmq, we cancel dmq, and then we'll be left with mole. All right, so what do we have? Let's divide 0.02 divided by 22.4, as we have in 0.00892. 0.00, how many zeros now? 3. 0.00892. Yeah, correct. Mole. All right, so we have done with question on mole relationship with gases at standard temperature and pressure. Up next, mole relationship with ideal gas. What do we do with that? So I need to clean up my board. I need the space. So this number 4. Now for the number 4, I need to know that I need to write my ideal gas equation, which says that PV is equals to nRT. Now, what are we looking for? We need to list out the parameters that we have. The P, okay, the P there is the pressure, which is in ATM, atmospheric pressure, all right? Then we have the V, which is in volume, and the volume is in dmq. All right, then we have the T, which is the temperature, and the temperature is in Kelvin. All right, what do we have again? Then we have the R, which is the general constant for ideal gas. Now the general constant for ideal gas is about 0.0821. Now, to get the unit, I don't need you to be afraid, all right? Now, let's look at the unit. So find the unit, because there are some chemistry exams or chemistry questions. They will say, what's the unit for the constant of general ideal gas constant R? What's the unit? All right, let's do something over here, just an addition, so that PV is equals to nRT, okay? So we're looking for R, all right? For now, because we want to get the units of this stuff. So I'm dividing by NT, I'm dividing by NT. This will kill this guy, so that the last thing I have is R. R is equals to PV NT. All right, please, what's the unit for P for pressure? ATM. So what's the unit for volume, because we have volume there, dmq. Now, what's the unit for number of mole? Mole. What's the unit for temperature? Kelvin. Now, if you do your indices, okay, if you do your little mathematics, what you're going to be having that R will be equals to the units now, that's what we're looking for, which is all of those here, is ATM times by DMQ, okay, times by per mole per Kelvin. All right, so this is the unit. So let's put it over here. ATM DMQ mole per Kelvin. All right, so we have gotten the unit. Let's move ahead to another thing. Now, some examiners will want you to find the unit of this. So you don't need to cram it, just know how to get it. Very important. All right, so we're looking for mole relationship with ideal gas. Okay, let's get let's make mole the subject of the formula. So I have that if I have PV is equal to nRT, I'm dividing by, okay, N is number of mole. I've not put that already. Number of mole, okay, which is, the unit is mole, correct? All right, so I'm dividing by what? RT. I'm dividing by what? RT. My N is equals to, what's my N now? This will kill this, PV RT. All right, let's give a question. Let's say 250 cm3 of ideal gas exerting a pressure. Calculate the number of mole present if 250 cm3 of ideal gas exert a pressure of 600 millimeter mercury at the temperature let's put 30 degrees. Okay, now there are so many conversions that we need to do here. We'll start from converting 250 cm3 to DMQ. That's the first conversion. So let's do our conversions. My pen is fainting. Check another one. We're converting volume. Volume is 250 cm3. Now we're dividing it by 1000. If we do that, we're going to get the volume in DMQ. All right, let's stretch up. Let's do it. All right, I have 250 divided by 1000. I'm having 0.25. All right, 0.25. So this is my new volume. Okay, I love this pen now. 0.25 DMQ. All right, that's my volume in DMQ. What I need to convert? Kelvin. Temperature is in degree. Convert it to Kelvin. So the temperature in Kelvin is 273, which is the constant for Kelvin, plus 30. So what should I have? 273 plus 30 now. 273 plus 30. Okay, I'm having 303. Okay, 303 Kelvin. All right, what am I converting again? All right, there is the pressure. The pressure is millimeter mercury. Understand that 760 millimeter mercury is equivalent to 1 atm. All right, I take that again. 760 millimeter mercury is equivalent to 1 atm. Now, we are going to convert 600 millimeter mercury to atm. So let's do the conversion. Let me use a red pen if it's not fainting. 600 millimeter mercury. Okay, that is what we are starting with. That's what we are given. 600 millimeter mercury is what we are given. So we are starting from there. So we are dividing it by 1. We'll use our conversion factor fraction. In our conversion factor fraction, we put 760 millimeter mercury in such a way that millimeter mercury will cancel out millimeter mercury. So I have 760 millimeter mercury gives me 1 ATM. All right, so millimeter mercury will cancel millimeter mercury. So what I have is 600 divided by 760. 600 times 1 divided by 760. Well, let's just straight up do it. 600 divided by 760. All right, I'm going to be having 0.789. So I have 0.789, correct? Yeah, 0.789. All right, that is ATM. Okay, now I have all my values converted. I have volume converted to DMQ. I have temperature converted to Kelvin. I have pressure converted to ATM. So I can solve now. Now let's clean up the board. I guess you have written the question, so let's clean up the board. Actually, we are looking for number of mole. They say calculate number of mole. Now, what do we have? PV is equals to nRT. All right, I'm looking for N. So I'm dividing by RT, divided by RT. My N is equals to PV RT. All right, can I solve that over there? All right, what's my P? The P is the P there. Let me use fainting pen. The P there is I'm looking for a sharp pen. Is 0.789. Okay. Now my V is 0.25 DMQ ATM, and my R is 0.0821. Is a constant. Is always a constant. Now my my T is 303 Kelvin. Okay, let's plug in what we have in our calculator, and then we'll get our answer. Calculator come now. All right. So we have what do I have? I have over there. I have 0.789. Okay, multiply by 0.25, and then I'm going to be dividing it by 0.0821. Okay, I'm multiplying that by 303. All right. My answer is 0.00792. The answer is 0.00792. I think I'm correct. 0.00792. Let me check that. 0.00792. All right. So what's my unit? The unit for mole is mole. Now let's have to solve question on relationship of mole with an ideal gas. So let's get to the last one. Relationship of mole with the elementary particles. Let's clean up the board. Relationship of mole with elementary particles. So that is number, this one is number 4. This one we're doing now is number 5. Relationship of mole with elementary particles. How do we solve that? Number of mole for elementary particles. Okay, for number of mole of elementary particles. Elementary particles equals to the number of particles divided by the Avogadro number, which is 6.02 times 10 raised to the power of 23 particles per mole. Particles per mole. All right. Now, number of mole relationship with elementary particles. The number of mole in elementary particles is simply the number of elementary particles divided by the Avogadro number of 6.02 times 10 to the power 23 particles per mole. All right, let's solve a problem. Let's say we have calculate the number of mole present present in 2 times 10 raised to the power of 22 atoms of sodium. Atoms of sodium. All right. Now, calculate the number of mole present in 2 times 10 raised to the power of 22 atoms of sodium. So when we're talking about atoms of sodium, elementary particles in chemistry, we're dealing with mole concept, we're dealing with stoichiometry. We're talking about elementary particles, we're talking about the atoms, we're talking about the molecules, we're talking about the protons, we're talking about the ions, we're talking about the electrons, molecules, a lot of those. Now, but here we are told atoms. So this can be molecule, all right? It can be any of those. So we have that number of, let's get this down, number of, let's make it E now, is number of particles. Let's just plug that in, which is 2 times by 10 raised to the power of 22, all divided by 6.02 times 10 raised to the power of 23. Okay, let's do that in, let's do that. What we have here is, we have here 2 times 10 raised to the power of, raised to the power of 22 divide by 6.02 times 10 raised to the power of 23. And what we're having 0.0033 atom, 0.033 atom. So I have 0.033 atoms of sodium. So this is the final answer for this guy, 0.033 atoms of sodium. This is all we've got for you in this video. If this video has helped you at all, give it a thumbs up and try to share to other students who will find this video helpful too. And then if it has helped you also, it has helped you well, you are free to follow for more. Thank you. Thanks for watching. Have a great day.